discuss. These are the points we have to discuss. A pace, what is pace, what is pace frame, what is hit, what is miss, what is hit ratio, what is pace replacement, what is dirty pace or dirty bit, and pace replacement policies. We have several types of policies we have, and thrashing, page table, and TLB, translation look aside buffer. So these are the points we should discuss. Okay, right. Let's get into the topic. First, what is page? We know that. So we are dividing the entire file into small parts. Those parts are called pages, right? Yeah, let's say paging is a virtual memory management system. It tells how information come from the virtual memory into your physical memory. That's it. So we can define a page as paging is a virtual memory management system. It tells how information comes from virtual memory to your main memory or physical memory. This is what your page. Okay, paging. And in simple terminology, how the information comes from your hard disk to your RAM. That's it. Paging means the simple terms in simple terms how the information comes from your hard disk to your RAM. So here your hard disk is your virtual memory, okay, and your RAM is your physical memory. That's it. Okay. First, the file stored in a hard disk. When you click on the file, that file comes from the hard disk to RAM. Okay, the information does not come in a single piece of file because there are several locations available in the RAM. There are several locations, there are huge amount of memory available in the RAM. Okay, that's why the information or the file does not come in a single piece of file. So you have you divide the entire file into small parts. Those parts are called pages. Okay, so that's the idea. Okay, that's the idea about, that's all about your paging or pages. Okay, right. So you divide the file into small parts called pages. The typical page size is 4 KB, though it can be changed for the higher processor or for modern processor. Okay, the typical page size is 4 KB in general, but but it can be changed for different processors. Okay, the higher processor may consist of more than 4 KB, more than 4 KB. Next, equal size blocks. Okay, if you observe here, equal size of blocks equal size of blocks are divided in main memory called page frames. Page frames. Just look at here. In the main memory, we have several blocks. All the blocks are of equal size. Okay, these blocks are called as known as page frame. So how many frames we have? Total 8 frames. That's the page frame number start from 0 to 7. Okay, so this is your main memory. Your main memory is divided into equal size of blocks. Those blocks are called as page frames. Okay, right. And obviously pages and page frames are smaller in size. When it comes to your virtual memory, all the virtual memory is also divided into equal size of blocks. Each block in your virtual memory is called as page. When it comes to main memory, the block name is called page frame. And when it comes to virtual memory, the block name is called as page. It's a unique address or unique number. Each page and page frame consists of it's a unique address. Okay, so page of virtual memory, that means whenever you want to process something, your process will transfer the information from virtual memory to main memory. That's it, right? Virtual memory to main memory. Okay, so when you are trying to transfer the information from virtual to memory to main memory means you are trying to getting the information from virtual memory pages to the main memory phase frames. Of course, both the page frame and the page size are equal. Both this page frame and the page size both are equal. Both are equal. Okay, and so the page of virtual memory comes into page frame of your main memory. Is this clear? Okay, the page of virtual memory, the page of virtual memory will comes into the page frame of your main memory. Okay, so what do you mean by page frame? The division of physical memory, right? Page frame means division of physical memory. Okay, and what do you mean by page? Page is a division of virtual memory. Division of virtual memory, right? Okay, so now we have seen how the entire main memory is divided and how the entire virtual memory is divided, right? Now, whenever the processor wants to process something or execute something, first it will check into the main memory. Okay, first it will check into the main memory. Let's say we have a song, some XX song, some X song. The processor wants to play it. The processor will first search in main memory. If the song is available in the main memory of any of these pages, then it's said to be hit. Okay, whenever the processor wants to search for something, if the file is found in the main memory, is said to be the result is said to be hit. Otherwise, in another case, if the file is not found in the main memory, then the result is said to be miss. Miss is also called as page fault. Page fault. Okay, so you know the hit, what is hit, what is miss. So page, page means a division of physical memory or main memory, and a page frame, sorry, page means division of virtual memory, page frame means division of physical or main memory, right? And hit, you know the hit, hit means if the file is available in the main memory, then it's called as hit. So what do you mean by miss? If the file is not available in the main memory while searching for, this result is said to be miss or page fault. Cache miss, cache hit. Okay, page fault. Cache miss is also known as page fault. Okay, next, hit ratio. Hit ratio, what do you mean by hit ratio? We can define the hit ratio as the number of hits upon total attempts. Okay, the number of hits upon total attempts is your hit ratio. Hit ratio, hit ratio means the number of hits. Number of hits means n1, right? Here it means n1 by upon total attempts. Total attempts means, total means both hit and miss. So this is your hit ratio formula, n1 by n1 plus n2. This is your hit ratio. Okay. Okay, and the hit ratio, it can never be more than 1. If it is more than 1 means this is not an healthy hit ratio. Okay, it can never be more than 1. Hit ratio is more than 97%. Hit ratio should more than 97 percentage. That means what I am trying to say is, whenever the processor wants to search for something, it should be available. Of course, most 97%, more than 97%, you will get the file in the main memory itself. Okay, that means the hit ratio is more than 97% for all the modern processors, all the modern main memories, all the modern processors, like your Pentium processor, your modern, all the modern processors will have more than 97% of hit ratio. If there is a 90, more than 97% hit ratio means it is a healthy hit ratio, healthy hit ratio. So whenever the hit ratio falls down below the 95%, means it's a bad hit ratio. It's said to be bad hit ratio. Okay. Now, so whenever there is a miss, the processor does not only get the data, so along with which it will get up, it will get, or it will copy entire page. For example, we have a information which is stored in the main memory. Okay, we have total how many files? Let's say 100 files over here, 100 files which is stored in the page frame number 1, and the processor wants to get this page frame 1 information. But in the page frame 1, there are only 99 files are available, one file is missing. There are 99 files are available, one file is missing. Though it missed only a single file, your main memory will not get that only single file. Instead of that, it will copy, or it will get the entire page from the virtual memory to the main memory. Okay, for example, take another example. In a page frame number 4, there are of 50 files, out of which one file is missed. That means 49 files are available. So which is refers to a single information, a single data. And out of this 50, one file is missed. So the processor wants to get this file, 50 files, or bunch of this 50 files, but one file is missed. So in this case also, your main memory will get the entire page from the virtual memory. It is not looking for only a single missed file. Instead of this, it will get the entire page from the virtual memory. Okay, is this clear? Next, so subsequent access to the page will result in hit. That means whenever there is a miss, even if it is a single file miss, is said to be a miss. Okay, even the file more than two files miss, then it is also said to be a miss, cache miss. Okay, so the subsequent access to the page will result in hit, cache hit. Okay, right. Okay, now page replacement. What is it? Page replacement. What do you mean by page replacement? Any page can be present anywhere in the main memory. Any page of your virtual memory can be present in any page frame of your main memory. Okay, so let's say this page 1 can store in page 6, this page 2 can store in page 2, this page 3 is can be stored in page frame number 4. so on. Okay, any of the page can be stored in any of the page frame of your main memory. Is this clear so far, guys? So by the time you come to page number 7, let's say, for example, this page number 1 is stored in page frame 0, and page frame 0 is stored in page frame 0, and page number 1 is stored in page frame 1, and so on up to your 7 page frame page. Your page 7 will stored in page frame 7. The moment when you come into 7, page number 7, your almost all the page frames are filled. There is no vacant, there is no empty page frames in the main memory. Okay, so your main memory is now full, so there is no empty page frame available. Okay, the page which is no longer no relevant is required, that will be removed. And for example, so here when it comes to the 7th page, your page frames are filled, there is no empty page frames over here. And at the same time, the page number 8 wants to store in the page frame number, any of this, but there is no vacant here, there is no space, there is no empty, there is no empty page frames here. So in that moment, any of these page frame can be removed and replaced with the uh, recent one. Okay, which is looking for the recent one. So that concept is known as page replacement. We are replacing the information, okay, right? Is this clear? The page. So what are the principles for replacement? The page which is no longer or no relevant may no longer relevant, no longer required, may be replaced. Okay, for example, I have 7 page frames over here. I have 7 from 0 to 7, and page frame number 4 is not being used since a so long time. And what is the use of this? Why should this page frame 4 is occupies our main memory, right? What is the advantage? What is the use of this having page frame number 4, as this page frame number 4 is no longer used, okay, no longer relevant, required. So what is the use of this? I can replace this, I can replace this page number 8 with page frame number 4. This concept is called as page replacement. Page replacement. Okay, irrelevant page will be replaced, irrelevant page will be replaced. Okay, come to a real time example. For example, I have opened 4 windows in my laptop. Let's say one Google Chrome page, one Word file, one Excel file, and I have minimized the Google Chrome and I'm working on the Excel sheet. Now, this Word file and Google Chrome both are in idle. I'm not using that. So, what is the use of that? Still, the 2 pages is occupied, 2 files are occupied in our main memory. So there is no use with this, right? So I can replace these 2 pages with some other. That's the idea, right? So whenever there is a page fault and there are no empty frames available in the main memory, your old page from main memory is replaced by a new page via virtual memory. This is called page replacement. I repeat, whenever there is a page fault, whenever there is a page fault and there are no empty frames available in the main memory. Old page from the main memory is replaced by the new page via virtual memory. This concept is called as page replacement. Is this clear so far? So almost this page replacement will be occurred only if there is a page cache miss. Okay, the page replacement will be occurred only if there is a cache miss. Is this clear, guys? Is this clear so far? Please tell me. Okay, so this is all about page replacement. Of course, there are several techniques for page replacement. When it comes to page replacement, we have we may get several queries. Which page should be replaced? Which page frame should be replaced? We have several techniques. FIFO, first in first out. LIFO, last in first out. Yeah, several. We have several techniques for page replacement. Okay, we'll discuss later those techniques. But what is the next concept? Dirty bit or dirty. Okay. What is next? Dirty page or dirty bit? Dirty page or dirty bit? Okay. Dirty page means you can simply say it's a modified page. Guys, please try to understand about a dirty page or dirty bit. Okay, let's have a look here. For example, this page number 3 is stored in page frame number 3, let's say. Okay, the moment when all the main memory page frames are filled, that means there are no empty space over here, you need to perform a page replacement, and you have to replace the page frame number 0. That means you have to remove this page frame number 3 from main memory. Am I clear? Right. So in this case, should I replace the page number new page directly blindly, or should I save the page frame number 3 and which has to be stored in the back in the virtual memory and replace? అంటే నేనేమంటానంటే డైరెక్ట్గా ఈ పేజ్ ఫ్రేమ్ నెంబర్ 3తో కొత్త పేజ్ ఏదైతే వస్తుందో దాన్ని బ్లైండ్గా రీప్లేస్ చేసేయవచ్చా, లేదంటే దీన్ని సేవ్ చేసి మళ్ళీ బ్యాక్ వర్చువల్ మెమరీలో మనం మళ్ళీ పెట్టేసి అప్పుడు రీప్లేస్ చేయాలా? దట్ ఈస్ మై క్వశ్చన్. ఓకే, what do you want to do? Should I replace the new page blindly, or should I save the existing page frame back
You
into
should say
main?
existing page.
Okay, right. But which we can't say, we can't copy, we can't replace it blindly, yeah, always, because for example, ఇందాక ప్రీవియస్ ఎగ్జాంపుల్ తీసుకోండి. నేను ఒక వర్డ్ ఫైల్తో వర్క్ చేస్తున్నాను. ఓకే, ఒక వర్డ్ ఫైల్ అండ్ ఎక్సెల్ ఫైల్, అలాగే థర్డ్ వన్ క్రోమ్, రైట్? ఈ ఫైల్స్తో వర్క్ చేస్తున్నాను. ఓకే, ఇంకా 7 ఫైల్స్ ఏదో ఉన్నాయి, బట్ మొత్తం నాకు ఇక్కడ మెయిన్ మెమరీ పేజ్ ఫ్రేమ్స్ మొత్తం అంతా కూడా వేకెంట్ లేదు. సో ఈ సిచ్యువేషన్లో నేను పేజ్ ఫ్రేమ్ నెంబర్ 3ని రీప్లేస్ చేయాలి. అదేం హోల్డ్ చేసింది అంటే నా ఎక్సెల్ ఫైల్ను హోల్డ్ చేసింది. సో నేను డైరెక్ట్గా సమ్ ఏదో మాడిఫికేషన్ చేశాను. ఓకే, డేటా ఎంటర్ చేశాను, సేవ్ చేశాను. సేవ్ చేయలేదు, బట్ ఏదో మాడిఫై చేశాను. ఇక్కడ నుంచి తీసుకొచ్చిన ఫైల్ అంటే ఇక్కడ చేసినామంటే ఆల్రెడీ చెప్పాను లాస్ట్ టైం, మెయిన్ మెమరీలో మాత్రమే మనం రీడ్ రైట్ ఆపరేషన్ చేయగలము అని. సో ఇక్కడ నుంచి తీసుకొచ్చాను, రీడ్ రైట్ సంథింగ్ ఏదో మాడిఫై చేశాను. ఇక్కడ నుంచి బ్యాక్ నేను స్టోర్ చేయాలా, సేవ్ చేయాలా, లేకపోతే డైరెక్ట్గా పేజ్ రీప్లేస్ చేయాలా నేను అడుగుతున్నాను. బట్ కంపల్సరీగా మనం బ్యాక్ చేయాలి. ఎప్పుడు అంటే ఇఫ్ దేర్ ఈస్ అన్ ఎడిట్, దేర్ ఈస్ అ మోడిఫికేషన్ ఏమైనా జరిగి ఉంటే కంపల్సరీగా మనం సేవ్ చేయాలి. తర్వాత బ్యాక్ వెళ్ళి ఆ పేజ్ని మళ్ళీ సేవ్ చేసేసి తర్వాత రీప్లేస్ చేయాలి. సో దిస్ కాన్సెప్ట్, దిస్ ప్రాసెస్ ఈజ్ సెట్ టు బి డర్టీ బిట్ ఆర్ డర్టీ పేజ్. సో ఏ పేజ్కి అయితే మనం సేవ్ చేసి తర్వాత మళ్ళీ మనం వెనక్కి వెళ్ళి సేవ్ మళ్ళీ సేమ్ ఆ ఫైల్ని మెయిన్ వర్చువల్ మెమరీలోకి మూవ్ చేసి అప్పుడు రీప్లేస్ చేస్తాము, పేజ్ రీప్లేస్ చేస్తాము, ఈ ఐడియాని, ఈ కాన్సెప్ట్ని డర్టీ పేజ్ అంటాం. ఏ పేజ్ అయితే అలా చేసామో దాన్ని డర్టీ పేజ్. ఎందుకు డర్టీ పేజ్ అన్నామంటే వి రిక్వైర్ వన్ మోర్ స్టెప్. ఓకే, డైరెక్ట్గా మనం ప్లేస్ చేయకుండా, డైరెక్ట్గా మనం పేజ్ రీప్లేస్ చేయకుండా దాన్ని మాడిఫై చేసాం కాబట్టి దాన్ని సేవ్ చేసి మళ్ళీ బ్యాక్ వెళ్ళి మళ్ళీ పెట్టేసి అప్పుడు మనం పేజ్ రీప్లేస్ చేస్తున్నాం. సో వీ నీడెడ్ అన్ ఎక్స్ట్రా స్టెప్. దట్స్ వై this process is called a dirty page or dirty bit. Okay, is this clear? Next, we have several page replacement algorithms. Already I told, right? And okay, next, thrashing. What is it? Next, thrashing. Coming to page replacement policies, we have several policies. FIFO, first in first out. LRU, least recently used, and LFU, least frequently used. So when it comes to page replacement, we have to follow some policies. Those policies are the those policies are FIFO, LRU, LFU. Okay. So for example, the moment when all the page frames are filled, that means there are no empty page frames in the main memory. Still, I need to get a new page from virtual memory to main memory. Okay. Then which page should replace will tell you these policies. FIFO. FIFO means first in first out. Let's say example Q, your Q, and for example somebody is distributing a laptops to students. Okay, let's say in a dean office members is distributing laptops. You should be in queue. The student who come first will leave first, right? So in that manner, the page frame which is come first will leave first, and that page frame will be replaced. That's the idea of FIFO, first in first out. And LRU, least recently used means ఏదైతే పేజ్ ఫ్రేమ్ మనం రీసెంట్గా యూజ్ చేయట్లేదో, నో లాంగర్ యూజ్, సో దాట్ పేజ్ ఫ్రేమ్ విల్ బి రీప్లేస్డ్. అది LRU. And LFU, least frequently used. And coming to thrashing, next, thrashing. What do you mean by thrashing? Thrashing means the situation when the hit ratio drops down below the 95%. If the hit ratio more than 97% means it's a healthy hit ratio. The moment when the hit ratio drops below the 95%, it means it's a bad hit ratio. Okay, too many page faults occur. Okay, too many page fall occur means it drops below the 95%, right? So whenever there is a bad hit means there is a chance to more bad page faults, right? What is the solution? We need to change the algorithm. Okay, the solution for this is we need to change the algorithm. Next concept is what? Translation. Next is translate. ఇక్కడ నేను రాయడం మర్చిపోయాను, బట్ ట్రాన్స్లేషన్ Translation means converting the virtual address into physical address is called translation. Address translation. Address translation means converting the virtual address to the physical address is known as address translation. Disconnect అయింది. మా అడ్రస్ ట్రాన్స్లేషన్ వినిపించిందా మీకు? అడ్రస్ ట్రాన్స్లేషన్ కన్ఫర్మ్ చేయండి. అడ్రస్
Yes, sir.
ట్రాన్స్లేషన్ నాకు ఓకే ఓకే అంటే ఇప్పుడు నెట్వర్క్ డిస్కనెక్ట్ అయిందని వచ్చింది. ఓకే, సో అడ్రస్ ట్రాన్స్లేషన్ మీన్స్ కన్వర్టింగ్ the virtual address into physical address. That's ఓకే. ఓకే, ఒకసారి ఇది చూడండి, దీంతో మీకు ఈజీగా అర్థమవుతుంది. లెట్స్ సే దిస్ ఇస్ యువర్ మెయిన్ మెమరీ. ఓకే, అండ్ దిస్ ఇస్ యువర్ virtual memory. Let's say we want to transfer the information from virtual memory to main memory. We have several pages over here. We have several page frames over here. Okay, and for example, your processor generates an address 42 and 5 or 45 5. This is your page number. The first part indicates it's a page number, and the second part indicates location in the page. Location in the page. Okay, so this is your virtual address. Let's say page 0, 1, 2, 3, 4, and so on. This is your page frame 0, 1, 2, and so on. For example, అండ్ ఇక్కడ ఒక విషయం గుర్తుపెట్టుకోవాలి, పేజ్ ఫ్రేమ్ సైజ్ అండ్ పేజ్ సైజ్ ఆర్ ఈక్వల్, అండ్ ద పేజ్ ఫ్రేమ్ నెంబర్ and page number will not change, remain same in both the memories. Okay, what I want to try to uh, convey is this location cannot change. This location cannot change in both the memories, and we have to look for this 45. Okay, right. Okay, just leave this. Just leave this. I'll tell the page table so that you will understand this concept clearly. Just leave it. Next concept is page table. Page table. Okay, what do you mean by page table? To keep a mapping of this pages from pages to the page frames, we need to keep a mapping information. We need a table. This table is called as page table. For example, ఇక్కడ మనం we are storing the information or data from virtual memory to main memory, and we need to keep information which page is stored in which frame number, which page information is stored in page frame. Those information should stored in a table. That table is known as page table. Okay, that table is known as page table. Your page table consists of two fields, that is This is your page table. So page frame number and page number. So this is called page table. Okay, this is called page table. So to go to any location in the main memory to get its physical address, you have to go to the physical table, page table. First, you have a virtual address. You took a page number, and to the page table, obtain page frame number, obtain with that location number. Okay, that's all. That means first you have to go to page table, then only you can find the page information will be get where the page is stored in the page frames. Is this clear? So with the help of page table, you can know where the particular page is stored in a page frame. That's it. So for which your processor will generate address. Based on the address, you will find the information. So this is the address. The address consists of two fields. The first field indicates a page number and second field indicates page frame. Let's say. So that's it. So this will inform you. For example, your processor generates address 42 comma 4. So this will be remain same for both main memory and virtual memory. So we ignore this one and we'll try to search the page number. So your page number, let's say 1 2 3 4 so on. There is a page number 42 over here, and this 42 will hold some information. That information is your actual address of your page frame. Of course, first the value is either 0 or 1. 0 means there is no page, there is no page frame exist. There is no page exist. If there is a 1 means, if there is a value 1 means your pages exist. In simple way, 0 means miss, 1 means hit. 0 means hit, 0 means miss, 1 means hit. Okay. So if there is a value 1, that means hit. That means the page frame holding some page information. So this will tells you where this page is stored in the page frame. So this is all about your page table. Guys, please understand this. Please try to understand this. Okay. Next, last one. What is translation look aside buffer? TLB. TLB. Okay. Now tell me whether the page table is smaller or bigger. Do you think that your page table is smaller? No, it's a large table. Your page table is a largest table. Even for finding something, you have to went through so many pages, so many searches. So instead of that, we can do one thing. We can put some memory, or we can say we can put a small table, a small piece of table inside the processor, inside the processor, so that the processor can look into this small piece of table instead of looking into main memory. So where does first of all, let me know, where does this page table show? Main memory. Of course, in main memory your page table is saved. Your page table will present in main memory. So instead of searching page table which is exists in the main memory, your processor will ask in the in the smallest table which is resides inside the processor. So this small table is known as buffer. Buffer, okay. Look aside means instead of looking into main memory, your processor is look into the small table which is resides inside the processor. This small table is known as buffer. So we are this process is looking into this buffer known as look aside buffer. Look aside buffer. For example, first our concept is the processor wants to process something for which it it wants to get the information, get the data from main memory. If the information is available in the main memory, well, good thing, then you will it's said to be hit. Okay, whenever there will be a file already exists in the main memory means it's cache hit, otherwise it's said to be cache miss. So if there is a miss means your processor will go to this virtual memory and get the page. Okay. So instead of searching in both the main memory and virtual memory, the processor will hold a small table inside the processor. This small table is called a buffer. Okay. This small table is called buffer. So that's all about today's class. So if you have any queries, you can ask me. Yes. Any questions? Any queries? Please, you can ask. No queries? No questions? No doubts? Questions, Yamleva? Tejasvi? I'm expecting questions from you. Doubts? Okay. No doubts? You may leave now. Okay. Great. First of all, let me know, is this concept clear? Is these concepts clear? మా ఈరోజు క్లాస్ అర్థమైంది అందరికీ?
సార్ బఫర్లోకి డేటా ఎలా ట్రాన్స్ఫర్ అవుతుంది సార్?
ఓకే. బఫర్లో డేటా అనే జస్ట్ అది ప్రాసెసర్ చూసుకుంటుంది. ఇంటెన్షనల్గా డెలిబరేట్లీ వీ కాంట్ డూ దాట్. సో అక్కడ స్టోర్ ఎలా చేసుకుంటుంది అంటే, ఏదైతే ఎక్కువ టైమ్స్ మనం ప్రాసెస్ చేస్తూ ఉంటామో, ప్రాసెసర్ ఫ్రీక్వెంట్గా ఏ డేటాని పిక్ చేసుకుంటుంటుందో ఆ డేటాని సో అందులో ప్లేస్ చేస్తాము, బఫర్లో స్టోర్ చేస్తాము. ఓకేనా? సో మనం ఇందాక సెవరల్ టెక్నిక్స్ ఉన్నాయి, పాలసీస్ ఉన్నాయి. ఫస్ట్ ఇన్ ఫస్ట్ అవుట్, లాస్ట్ ఇన్ ఫస్ట్ అవుట్, లీస్ట్ రీసెంట్లీ యూజ్డ్. సో మోస్ట్ ఫ్రీక్వెంట్లీ యూజ్డ్ ఏదైతే ఉందో ఆ ఇన్ఫర్మేషన్ అంతా కూడా బఫర్లో స్టోర్ అయి ఉంటుంది. సో బఫర్లో స్టోర్ అవడం వల్ల మనం మెయిన్ మెమరీకి వెళ్ళాల్సిన పని లేదు, అండ్ వర్చువల్ మెమరీకి అసలు వెళ్ళాల్సిన పని లేదు. సో దట్ we can increase the speed, process speed. Okay. We can't store the information deliberately in what do you say, buffer. Okay, clear?